Imagine, for a moment, the cold silence of space, for million miles from Earth, where a telescope the size of a tennis court is looking at something it was never designed to find. The James Webb Space Telescope has discovered a world that scientists are calling Earth 3.0. It has water. It has clouds. It has an atmosphere that should not exist unless something is breathing there. But here is where the story takes a turn that no one expected. The data coming back from this distant world contains patterns, signals, rhythms that repeat in ways that nature alone cannot explain. Something is already there, and whatever it is, it knows we are watching. If you are someone who loves exploring the mysteries of the cosmos with us, take a moment right now to hit that like button and subscribe to Cosmic Drift. Your support helps us bring you more incredible journeys through the universe. Now, let us continue into the unknown together. To understand why this discovery is shaking the foundations of everything we thought we knew, we need to start at the beginning. Not the beginning of the universe, though we will get there eventually. We need to start with a question that has haunted humanity since the first person looked up at the night sky and wondered if those tiny points of light might be other suns, other worlds, other lives. Are we alone? For most of human history, that question lived in the realm of philosophy and religion. It was not something science could touch. The stars were too far away. The universe was too vast. We had no tools powerful enough to peer across the cosmic ocean and see what waited on distant shores. But that changed slowly at first and then all at once. Every culture on Earth has gazed at the night sky and imagined what might be out there. Ancient peoples saw gods and ancestors in the patterns of stars. Medieval scholars debated whether the heavens could contain other inhabited worlds. Renaissance thinkers, emboldened by the Copernican revolution, began to suspect that our sun was just one of many and that those other suns might have their own Earths orbiting them. By the 20th century, the question had become scientific. Astronomers confirmed that the stars were indeed other suns, some larger and some smaller than our own, but fundamentally similar. They discovered that our galaxy contained hundreds of billions of stars, and that the observable universe contained hundreds of billions of galaxies. The numbers were staggering. How could we possibly be alone in such an incomprehensibly vast cosmos? And yet we had no evidence either way. The distances were too great. The technologies too limited. We could speculate and calculate probabilities, but we could not know. The question remained what it had always been, the greatest mystery in all of existence. Radio astronomers pointed their dishes at the stars, listening for artificial signals. They heard nothing but static. Space probes visited every planet in our solar system and found no signs of intelligence. Mars, once thought to be inhabited by an advanced civilization, turned out to be a frozen desert. The universe seemed stubbornly empty. Some began to wonder if we really were alone. Perhaps life was rarer than we had assumed. Perhaps intelligence was a fluke, a one-time accident that had happened only here on this one small world in this one small corner of existence. Perhaps the silence of the cosmos was telling us something we did not want to hear. But others refused to accept that conclusion. They pointed to the immensity of the universe, to the billions of years available for life to evolve, to the basic chemistry that seemed to favor the emergence of biological systems. Absence of evidence, they argued, is not evidence of absence. We just needed better tools. The story of how we got here, how we built a machine capable of finding Earth 3.0, is a story of human determination, brilliant engineering, and decades of work by thousands of people who refused to accept that some questions were too big to answer. The James Webb Space Telescope did not appear overnight. Its roots stretch back to 1989, just 3 years after the Hubble Space Telescope launched and changed our view of the cosmos forever. Even as Hubble was revealing the beauty of nebulae and the depths of distant galaxies, scientists were already dreaming of something bigger, something better, something that could see not just the light we can observe, but the invisible light that carries secrets from the dawn of time. You see, the universe is awash in light we cannot see with our eyes. Infrared light, heat, this is the language of the cosmos. The way the universe whispers its deepest secrets. Stars being born in clouds of gas and dust speak in infrared. Ancient galaxies at the edge of the observable universe have had their light stretched by the expansion of space until it glows only in infrared. And planets orbiting distant stars, worlds that might harbor life, reveal their secrets through the faint infrared signature of their atmospheres. To hear these whispers, we needed a new kind of telescope. One that could collect infrared light with unprecedented sensitivity. One that could see farther and more clearly than anything humanity had ever built. One that would have to work perfectly millions of miles from Earth in the cold darkness between our world and the sun. The challenges were staggering. Infrared telescopes have a problem that optical telescopes do not face. They detect heat and everything gives off heat. Your body, your computer, the walls of your room, the telescope itself. If you want to see the faint infrared glow of a distant planet, you need your telescope to be cold. Incredibly cold. Colder than anything on Earth. The James Webb Space Telescope was designed to operate at temperatures below -400 degrees Fahrenheit. At those temperatures, the instruments become sensitive enough to detect the heat of a bumblebee on the moon. But keeping something that cold in space required solving engineering problems that had never been attempted before. The solution was elegant and audacious. Webb would carry a sun shield the size of a tennis court made of 5 layers of a material called Kapton, each layer thinner than a human hair. This shield would block the heat of the sun, allowing the telescope to cool to the temperatures it needed to function. But the shield was too big to fit inside any rocket. It would have to be folded like origami, launched into space, and then unfold itself automatically millions of miles from any helping hand. The primary mirror presented its own challenges. To collect enough light to see the faintest objects in the universe, the mirror needed to be huge, 21 feet across, far too large to fit inside a rocket as a single piece. So engineers designed it as 18 hexagonal segments, each one coated with a layer of gold only a few atoms thick. Gold is an excellent reflector of infrared light. The segments would be folded for launch and then unfold in space, aligning themselves with a precision measured in nanometers. 1 nanometer is 1/1,000,000th of a meter. For comparison, a human hair is about 80,000 nanometers wide. Year after year, the teams working on Webb solved problem after problem. They invented new technologies. They tested every component exhaustively. They prepared for every failure mode they could imagine, and many they could not. The original launch date of 2007 slipped, then slipped again. Budget problems emerged. Political fights threatened to cancel the project entirely. But the dream persisted. The telescope was too important. The questions it might answer were too profound. And so the work continued through 2 decades of setbacks and breakthroughs, through economic crises and political changes, through the dedication of scientists and engineers who devoted their careers to building something that might reshape humanity's understanding of its place in the cosmos. On Christmas morning 2021, the James Webb Space Telescope finally left Earth. It rode into the sky on an Ariane 5 rocket launched from French Guiana on the northern coast of South America. Controllers held their breath as the rocket carried its precious cargo away from our world. There could be no rescue mission, no repair crew. If anything went wrong, 2 decades of work and $10 billion would be lost forever. But nothing went wrong. Or rather, nothing went wrong that the teams had not prepared for. The launch was so precise that Webb had extra fuel left over, extending its potential mission lifetime far beyond the original 10-year plan. The sun shield deployed perfectly, all 5 layers separating and stretching tight. The primary mirror unfolded, all 18 segments clicking into place like a golden flower blooming in the void. Webb traveled for a month to reach its destination, a special point in space called the second Lagrange point, or L2. This is a gravitational balancing spot about 1,000,000 miles from Earth on the side away from the sun. At L2, the telescope can keep its sun shield pointed at the sun, while its instruments face the dark cold of deep space, always ready to receive the faint light from distant worlds. The first images from Webb stunned the world. Galaxies older than any we had seen before, their light having traveled for more than 13 billion years to reach us. Stellar nurseries where new stars were being born, their swirling clouds of gas and dust revealed in stunning detail. The atmosphere of an exoplanet analyzed with enough precision to identify individual molecules in its alien air. These images made headlines around the world. They showed that the decades of work and billions of dollars had been worth it. Webb was performing better than specifications in almost every category. The universe was opening up before us as never before. In research centers and universities across the planet, scientists pored over the data. Each image contained more information than any single person could analyze. Teams divided the work, each focusing on their area of expertise. Cosmologists studied the distant galaxies. Star formation experts examined the stellar nurseries. Planetary scientists analyzed the exoplanet atmospheres. The public watched with a mixture of wonder and impatience. The images were beautiful, but where were the aliens? After all the anticipation, all the promises about what Webb could do, people wanted to know, were we alone? The scientists counseled patience. Finding signs of life, if it existed, would take time. The data had to be collected carefully, analyzed rigorously, checked and rechecked. Science could not be rushed. The universe had waited 13 billion years to be understood. A few more months or years would not matter. But even the scientists had to admit privately that they hoped for something more. They had dedicated their careers to understanding the cosmos. They knew the odds. They knew that habitable planets might be common, that life might arise wherever conditions permitted. They dared to hope that their generation would be the one to make the ultimate discovery. Webb was working better than anyone had dared to hope, and it was about to find something that would change everything. The discovery of Earth 3.0 did not happen in a single dramatic moment. Science rarely works that way. It came through the patient accumulation of data, through observations that seemed routine until suddenly they were not. The target was a star called Kepler 442, a K-type dwarf star located about 1,200 light-years from Earth in the constellation Lyra. This star had been of interest to astronomers for years because the Kepler Space Telescope, Webb's predecessor, had detected a planet orbiting it. Kepler 442b, as it was called, sat in the habitable zone, that sweet spot around a star where temperatures might allow liquid water to exist on a planet's surface. But Kepler could only tell us that the planet existed and roughly how big it was. Could not tell us what kind of world it really was. Rocky like Earth, gaseous like Neptune, covered in oceans or barren as Mars. Those questions required a different approach. They required looking at the planet's atmosphere. When a planet passes in front of its star from our perspective, a tiny fraction of the starlight filters through the planet's atmosphere before reaching us. Different molecules absorb different wavelengths of light. By analyzing which wavelengths are missing or weakened, scientists can determine what gases are present in an alien sky. This technique, called transmission spectroscopy, is one of Webb's greatest strengths. The observations of Kepler 442b began as part of a larger survey. Webb was scheduled to study dozens of potentially habitable worlds, building up a picture of how common Earth-like atmospheres might be. No one expected any single observation to produce earth-shaking results. The universe, after all, is a big place, and we had looked at many worlds without finding clear signs of life. The first data showed something interesting: water vapor, lots of it, more than models predicted for a planet that size. The research team noted it as intriguing and scheduled follow-up observations. Water is necessary for life as we know it, but it is not proof of life. Many dead worlds have water. The second set of data showed something else: oxygen. Not trace amounts, but substantial quantities, enough to suggest active processes replenishing the atmosphere. On Earth, our oxygen comes primarily from photosynthesis. Plants and cyanobacteria pump it out constantly. Without them, our oxygen would slowly react with other elements and disappear. Now the team was paying attention. Water and oxygen together were a powerful combination. Still not proof, but suggestive. They requested priority observation time. Webb turned its full attention to this one small world orbiting a distant star. The third set of data changed everything. Hidden in the atmospheric signature, barely visible above the noise, was something that should not have been there: methane. Significant amounts of methane coexisting with significant amounts of oxygen. To understand why this matters, you need to understand a bit of chemistry. Methane and oxygen do not like each other. When they meet, they react. The methane combines with the oxygen and both are destroyed. On a planetary scale, this reaction happens relatively quickly in geological terms. If you have a lot of both gases in an atmosphere, something must be constantly producing them. On Earth, that something is life. Cows produce methane. Termites produce methane. Bacteria in swamps and ocean floors produce methane. Meanwhile, plants and algae produce oxygen. The two gases are in constant conflict, constantly being replenished by living things. Finding both gases together in the atmosphere of Kepler 442b was like finding smoke without fire. The smoke should not persist unless something keeps generating it. The simplest explanation, the one that required the fewest assumptions, was that this planet had an active biosphere, living things, alien life. But the team was careful. Science demands skepticism of extraordinary claims. There had been false alarms before. Mars had seemed to show signs of methane that turned out to be measurement errors or unusual chemistry. They needed to rule out non-biological explanations before they could say what they suspected. Could volcanoes produce the methane? They ran the numbers. The volcanic activity required to produce that much methane would also produce other gases that were not present. The volcanic explanation did not fit. Could photochemistry in the upper atmosphere explain it? They modeled the chemistry. The models could not reproduce the observed ratios without some unknown process. Could there be exotic geological processes they had not considered? They consulted experts from every relevant field. No one could offer a non-biological explanation that fit all the data. Weeks turned into months as the team double-checked everything. They reanalyzed the raw data. They recalibrated the instruments. They ran the observations again and got the same results. Whatever was producing the methane and oxygen on Kepler 442b was doing it continuously and in substantial quantities. The preliminary paper was drafted and redrafted. The conclusions were stated carefully with all appropriate caveats. Science does not deal in certainty, only in probabilities. But the probability that something was alive on this distant world was high enough that the team felt comfortable saying what they had found. Kepler 442b showed strong evidence of biological activity. The planet was not just potentially habitable. Something was actually living there. The news spread through the astronomical community like wildfire. Other observatories pointed their instruments at the star. Independent teams confirmed the atmospheric readings. The data was solid. The chemistry was clear. Unless our understanding of atmospheric science was fundamentally wrong, Kepler 442b harbored life. But that was only the beginning of the story, because as astronomers continued to watch and analyze, they found something else. Something that transformed an already historic discovery into something far more profound and far more unsettling. The follow-up observations required patience. Webb had many demands on its time, and the team had to wait their turn in the observation queue. But when their window came, they made the most of it. They observed Kepler 442b for hours at a stretch, gathering as much data as the telescope could collect. The infrared sensors were the key. These instruments could detect heat with extraordinary precision, measuring temperature differences of just a fraction of a degree from 1,200 light-years away. The data they produced was a kind of heat map of the planet, showing which areas were warmer and which were cooler. The initial analysis was straightforward. The planet's day side was warmer than its night side. As expected, the equator was warmer than the poles. There were variations that corresponded to what might be continents and oceans, with water holding heat differently than land. But then the anomalies started appearing. The infrared data from Kepler 442b showed thermal patterns on the planet's surface. Hot spots and cold spots changing over time as the planet rotated. This was expected. Any world with an atmosphere would have weather, temperature variations, differences between day and night. But the patterns were strange. Some of the hotspots appeared in places where they should not be. Areas that, based on the planet's geography and the angle of starlight, should have been cool were radiating excess heat. The differences were small but measurable. They were also regular. The hotspots appeared and disappeared in cycles. Not the cycles of days or seasons, shorter cycles. Cycles that repeated with almost mechanical precision. One researcher working late at night going through the data made an observation that she almost dismissed as impossible. The hotspots were not random. They were clustered, and the clusters formed shapes. She ran the analysis again and again. The shapes persisted. They were not natural formations. They were too regular, too geometric, too obviously artificial. Something is down there that has been produced by intelligent design. Those were the words she wrote in her notes. Words that would later become famous. At the time, she did not share them with anyone. The claim was too extraordinary. She needed more evidence. Over the following weeks, she gathered it. The thermal pattern showed clear signs of structure. Straight lines where no geological process could produce them. Grid patterns. Concentrations of heat that suggested not volcanism, but industry, warmth being produced and released in ways that matched the rhythms of activity rather than geology. The analysis expanded. More researchers were brought in. Computer algorithms were set to work finding patterns in the data. The conclusion became inescapable. Kepler 442b did not just have life, it had civilization. The term Earth 3.0 emerged from the early discussions among the research team. It was not meant to be a formal designation, just a shorthand for what they were seeing. A world with water, oxygen, methane, and signs of technological activity. A world that had apparently followed a path similar to our own, developing not just biology but intelligence and industry. Earth 1.0 was our own planet, the original. Earth 2.0 had been a term used for various planets that resembled ours physically but showed no signs of life. Earth 3.0 was something new, a world that was not just habitable but inhabited. Not just alive, but awake. The implications were staggering. For all of human history, we had wondered if we were alone. Now we had evidence that we were not. Somewhere out there, around a star we could see in our night sky, beings were living their lives, going about their business, completely unaware that a small blue world called Earth had just discovered them. Or were they unaware? As the analysis continued, something became clear that added another layer of complexity to an already complex situation. The thermal patterns were not static. They were changing not just in the cycles of what might be daily or weekly activity. They were changing in response to our observations. This sounds impossible, so let me explain carefully. The James Webb Space Telescope is essentially passive. Collects light. It does not send signals to the objects it observes. There is no way for anything on Kepler 442b to know that it is being watched, at least not through any detection of Webb itself. But we are not the only ones who build telescopes. If there is a civilization on Kepler 442b, they might have their own instruments pointed at the sky. They might have noticed our star, Sol, and wondered about it, just as we wondered about theirs. They might have built their own astronomical tools capable of detecting signs of technology in the atmospheres of planets orbiting distant stars. Our planet, after all, has been broadcasting its presence for over a century. Radio waves from our communications have been spreading outward at the speed of light since the early 20th century. Our atmosphere is rich with industrial chemicals that any sufficiently advanced civilization could detect. The city lights on our night side glow brightly in thermal imaging. Kepler 442b is 1,200 light-years away. That means light, including radio waves, takes 1,200 years to travel between our worlds. Any signals we send today would not arrive there until more than a millennium from now. Any signals they sent today would not arrive here for just as long. But here is the thing, we have been here for a long time. Our technological civilization has been visible in principle for over a century. If they detected us 50 years ago, they might have decided to do something about it. Something that would take time to implement, something that would become visible to us only when enough time had passed. The thermal patterns that the research team was observing included structures that appeared new, developments that seemed recent, construction, if that is what it was, that had taken place within the last few years of observational data. Coincidence? Perhaps. We cannot know for certain, but the timing was suggestive. It was as if upon learning that another civilization existed in the cosmos, they had decided to build something in response, something visible, something meant to be seen. The researchers debated endlessly about what this might mean. Were they trying to communicate? Were they showing off their capabilities? Were they sending a warning? Or was it all unrelated to us? The activities of an alien civilization going about its own business for its own reasons. The only thing everyone agreed on was that the discovery raised more questions than it answered. We had found that we were not alone. We had found that the universe contained other minds, other lives, other civilizations. But we had no idea what they wanted, what they thought, or how they might respond to our discovery of them. And so humanity stood at a threshold. Behind us lay all of history, all the millennia of wondering and dreaming and fearing what might be out there. Ahead lay an unknown future shaped by a discovery that would force us to reconsider everything we thought we knew about our place in the cosmos. The discovery of Earth 3.0 was not just a scientific achievement. It was an existential event. The kind of moment that comes along perhaps once in the history of a species. The moment when you learn that you are not alone. Let us take some time to understand this planet, this Earth 3.0, in more detail. What do we actually know about Kepler 442b, and what can we infer from the data? The basics are well established. The planet orbits its star at a distance of about 37 million miles, completing one orbit every 112 Earth days. This puts it firmly in the habitable zone of its star. Kepler 442 is smaller and cooler than our Sun, so the habitable zone is closer in. The star itself deserves attention. Kepler 442 is what astronomers call a K-type main sequence star, also known as an orange dwarf. It is about 60% as massive as our Sun and about 35% as luminous. Stars like this are extremely common in the galaxy, far more common than Sun-like G-type stars. If life and civilization can arise around K-type stars, then the number of potential homes for intelligence in our galaxy increases dramatically. K-type stars also live longer than our Sun, much longer. While our Sun will exhaust its fuel in about 5 billion years, K-type stars can burn steadily for 15 to 30 billion years. This gives life more time to evolve and civilizations more time to develop. The beings of Kepler 442b might have been around for longer than life has existed on Earth. They might have depths of history we cannot fathom, or they might be younger than us. We cannot tell from the data we have. The age of a civilization is not written in its thermal signatures. We see what they are, not when they began. The planet itself is about 1 1/3 times the diameter of Earth, making it what astronomers call a super-Earth. Its mass is harder to determine precisely, but estimates suggest it is roughly twice as massive as our world. This would give its surface gravity about 1.2 times Earth normal. Not uncomfortable for human visitors, though we would feel noticeably heavier. The term super-Earth might sound dramatic, but it simply refers to planets larger than Earth but smaller than Neptune. Many super-Earths have been discovered, and they appear to be one of the most common types of planets in the galaxy. Finding a habitable super-Earth with signs of life suggests that such worlds might be even more hospitable to the development of civilization than Earth-sized planets. Why might larger planets be better for life? Several reasons have been proposed. Larger planets can hold thicker atmospheres, providing better protection from radiation and better regulation of temperature. They have stronger magnetic fields which deflect harmful particles from their stars. They have more geological activity which recycles nutrients and regulates atmospheric composition over long time scales. Of course, planets can also be too large. Giant planets like Jupiter and Saturn have crushing gravity and no solid surface. The sweet spot for life appears to be in the super-Earth range, large enough to have the benefits of size, but not so large as to become a gas giant. Kepler 442b falls right in this sweet spot. The atmosphere appears to be primarily nitrogen like Earth's, with significant amounts of oxygen, water vapor, and trace gases including methane and carbon dioxide. The proportions are different from our atmosphere, but not wildly so. An unprotected human on the surface would not be able to breathe the air directly, but it would not be immediately toxic either. With proper filtration and oxygen supplementation, survival would be possible. The surface temperature varies with location and time of day, but averages in the range comfortable for life as we know it. The thermal data suggests the presence of large bodies of liquid water, almost certainly oceans. The planet appears to have both polar and tropical regions with weather patterns that suggest active circulation in the atmosphere. All of this would be remarkable enough for any newly discovered exoplanet. Finding a world so similar to Earth at all was a major achievement. But it was the signs of technology that transformed this from an important discovery into a historic one. The thermal signatures consistent with industrial activity are concentrated in several locations on the planet's surface. Based on the timing of their appearance and disappearance as the planet rotates, researchers have mapped out approximately where these regions are. The highest concentrations appear to be on a landmass in the southern hemisphere and along the coast of a large continent in the northern hemisphere. The pattern suggests cities, large urban areas generating heat through the daily cycles of activity, brighter at certain times and dimmer at others. The regularity of the patterns implies organization, infrastructure, routines, civilization. Beyond the cities, there appear to be other structures. Linear features connecting the urban areas, possibly transportation networks. Scattered hotspots that could be factories or power plants. Agricultural regions that show different thermal signatures than wildlands. All of this is interpretation, of course. We are inferring a great deal from limited data. The thermal resolution we can achieve from this distance is measured in hundreds of miles. We cannot see individual buildings or vehicles. We cannot read their signs or watch their people. We can only see the gross thermal output of a technological civilization and try to make sense of the patterns. But the patterns are there unmistakably. The longer we look, the more details emerge. And the more details emerge, the clearer it becomes that we are looking at something real. A civilization, a people, beings going about their lives on a world 1,200 light-years from our own. Who are they? What do they look like? What do they think? What do they want? These are questions we cannot answer with current technology. The distances involved are simply too vast. Even our best telescopes can only see them as patterns of heat on a distant world. But we can speculate. We can consider what the conditions on their world would have produced and what kind of beings might have evolved there. The surface gravity is higher than Earth's, which suggests that life forms there might be more compact, more powerfully built, adapted to moving under greater gravitational stress, but not dramatically different. The difference between their gravity and ours is similar to the difference between living at sea level and living in the mountains. The atmosphere has a higher proportion of oxygen than ours, which could support more active metabolisms. Creatures might be able to sustain higher levels of activity. Alternatively, the life forms might have evolved to use that oxygen more efficiently with tissues that resist oxidative damage better than ours. The star they orbit is cooler and redder than our sun. Plants on their world, if they have plants, would likely be darker in color, optimized to absorb the wavelengths of light their star produces most abundantly. Their sky might appear a different color than ours, the familiar blue replaced by something more amber or even a deep red. Beyond these broad speculations, everything is uncertain. Evolution is opportunistic. It produces whatever works, not whatever makes sense to outside observers. The beings of Kepler 442b might be humanoid, or they might be something we could barely recognize as alive. They might have senses we lack or lack senses we take for granted. Their thoughts might be comprehensible to us or utterly alien. What we can say with some confidence is that they are technological. They have built things. They have altered their environment in ways visible from over 1,200 light-years away. This suggests certain commonalities with humanity, at least in terms of capabilities. To develop technology, you need hands or something like them, appendages capable of manipulating the physical world with precision. You need a nervous system complex enough to support abstract thought, planning, and communication. You need a social structure that allows knowledge to be accumulated and passed between generations. You need curiosity, the drive to understand and control your environment. In these ways, at least, the beings of Kepler 442b must be like us. Different in countless details, no doubt. Products of a separate evolutionary history on a separate world under a separate star, but recognizably similar in their fundamental relationship to the universe. Minds that wonder, hands that build, civilizations that grow. And that brings us to the most profound question raised by this discovery. What does it mean for us? How should humanity respond to the knowledge that we are not alone? The debate began even before the research was made public. The team that analyzed the data argued about whether to release it at all. Some felt that the implications were too significant, that world governments should be consulted before an announcement was made. Others argued that science had to be open, that hiding such a discovery would be a betrayal of everything research stood for. In the end, the decision was made to publish. The paper appeared in a leading scientific journal, peer-reviewed and vetted through the normal channels. The announcement was made at a press conference that drew every major news organization in the world. The reaction was everything you might expect and more. Joy, fear, wonder, denial. Religious leaders scrambled to reconcile the discovery with their doctrines. Political leaders issued statements ranging from cautious optimism to apocalyptic warning. Stock markets briefly panicked before stabilizing. Social media exploded with speculation, memes, conspiracy theories, and genuine awe. Some people celebrated. For them, the confirmation that we were not alone was the answer to a lifelong hope. The universe was alive, teeming with intelligence, full of possibilities we were only beginning to imagine. Others feared. The history of encounters between civilizations on Earth offered little comfort. When two cultures met and one was technologically superior, the results for the lesser civilization were often catastrophic. Were we the lesser civilization now? Were we in danger from beings we could not understand and could not resist? Still others simply could not accept the news. They had built their worldviews around human uniqueness, and this discovery shattered that foundation. They called the findings faked, the data manipulated, the conclusions premature. They accused the researchers of seeking attention or funding. They denied the reality that the evidence made clear. And many, perhaps most, simply went about their lives. The beings of Kepler 442b were very far away. Whatever they were doing over there had no immediate impact on the daily concerns of people here. Rent was still due. Children still needed to be fed. Jobs still demanded attention. Life continued even as the universe revealed itself to be stranger and more populated than anyone had known. But even those who set the news aside and focused on daily life had been changed by it. The sky looked different now. Those stars were not just points of light anymore. They were potential homes, possible civilizations, distant neighbors in a cosmic community we were only beginning to discover. The philosophical implications ran deep. For centuries, thinkers had debated whether intelligence was common or rare in the universe. Some argued that the conditions for life were so specific, the evolutionary path to intelligence so narrow, that we might be alone in the cosmos. Others contended that life would arise wherever conditions permitted, that intelligence was an inevitable consequence of biological evolution, that the universe must be teeming with minds. The discovery of Earth 3.0 did not settle the debate entirely, but it shifted the odds dramatically. One data point is not conclusive, but it is not nothing either. If we found a technological civilization around the very first habitable planet we looked at carefully, that suggested such civilizations might be common. The universe might be full of them waiting to be discovered. And if civilizations were common, why had we not heard from them before? This was the essence of the famous Fermi paradox, named after the physicist Enrico Fermi, who reportedly asked, "Where is everybody?" If intelligent life was common in the galaxy, why was the galaxy not obviously full of it? Why had we not received clear signals, been visited by explorers, found artifacts of ancient civilizations? The discovery of Kepler 442b suggested one possible answer. Perhaps civilizations were common, but communication was rare. 1,200 light-years meant any exchange of messages would take 2,400 years for a question and answer. Perhaps civilizations simply waited in their own solar systems, aware of each other but not communicating, separated by the vast and silent spaces between the stars. Or perhaps the civilizations communicated in ways we could not yet detect. Perhaps they had moved beyond radio waves to technologies we had not invented. Perhaps the galaxy was buzzing with conversation and we simply did not have the equipment to hear it. Or perhaps, most troublingly, there was something that prevented civilizations from expanding beyond their home worlds. Something that stopped them, destroyed them, or changed them into something that no longer wanted to explore. The Great Filter, some called it. A barrier that few or no civilizations managed to pass. Were we past the filter or approaching it? Was our future bright with discovery and expansion? Or was there something ahead that would end our journey before it truly began? The beings of Kepler 442b had apparently survived long enough to build a visible civilization. Did that mean they had passed their filter? Or were they like us, still approaching it? These questions had no clear answers. They might never have clear answers. But the discovery forced us to confront them in ways that had previously been merely theoretical. The questions were real now. The stakes were real. The universe was alive with intelligence, and we had to figure out what that meant for us. The cultural response to the discovery was as varied as human culture itself. Artists, writers, musicians, and filmmakers found in it an endless source of inspiration. Within months of the announcement, galleries were filled with works imagining life on Kepler 442b. Novels were written exploring the implications of contact. Music captured the awe and terror and wonder that the discovery evoked. Some of this art was optimistic, depicting futures where humanity and the beings of Kepler 442b became partners in exploring the cosmos. Others were darker, imagining conflicts and catastrophes that contact might bring. Still others were simply meditative, trying to capture the profound strangeness of knowing that we were not alone. The philosophical response was equally varied. Existentialist thinkers argued that the discovery made human existence more meaningful, not less. We were part of something larger, participants in a cosmic drama that gave our brief lives significance. The fact that others existed did not diminish us. It connected us to a universe that would otherwise have been empty and meaningless. Others took the opposite view. If intelligence was common, then humanity was not special. We were one civilization among many, perhaps countless. Our achievements, which had seemed so remarkable when we thought we were alone, were simply the typical accomplishments of a typical species on a typical planet. Pride in human uniqueness was no longer justified. Still, others argued that the question of meaning was unchanged by the discovery. Meaning came from within, from the values and purposes that individuals and societies created for themselves. Whether the universe contained one intelligence or a billion, that fundamental truth remained the same. The academic world mobilized to study every aspect of the discovery. New departments and institutes were established at universities around the world. Funding poured into fields that had previously struggled for recognition. Astrobiology, xenolinguistics, comparative planetology, and a dozen other disciplines emerged or expanded. Young people flocked to these fields, inspired by the discovery and eager to contribute to the next chapter of the story. The best minds of a generation turned their attention to questions that had once seemed purely speculative. What is the nature of alien intelligence? How might communication be established? What are the limits of technology? What is the ultimate fate of civilizations? These questions would occupy humanity for generations. But they were no longer merely theoretical. They were practical questions with real stakes and real consequences. The discovery had transformed the nature of inquiry itself. In the loud months following the announcement, the world began to adjust. The immediate shock faded into a kind of new normal. The beings of Kepler 442b became a topic of casual conversation, something people discussed at parties and debated on forums. Art and literature emerged imagining what the aliens might be like. Music was composed in their honor. Religions evolved new doctrines to encompass them. Scientific institutions reorganized their priorities. The search for extraterrestrial intelligence, once a somewhat fringe pursuit, became a central focus of astronomy. New instruments were proposed and funded. International cooperation increased as nations recognized that this was a challenge too big for any one country to address alone. Plans began to form for how humanity might respond. Should we send a message? So, what should it say? Who should speak for Earth? How could we represent the diversity of human civilization to beings who knew nothing about us? These questions were complicated by the time delay. Any message we sent would take 1,200 years to arrive. Any response would take another 1,200 years to return. The people who sent a message would not live to receive an answer. Their grandchildren's grandchildren might not live to receive an answer. This was communication across generations, across centuries. It required a kind of patience and long-term thinking that human institutions were not designed for. It required us to act not for ourselves but for our descendants, trusting that they would continue what we started. Some argued that we should not send a message at all. The beings of Kepler 442b knew we were here. Our civilization had been broadcasting its presence for over a century. But we had not deliberately attracted their attention. Not yet. Perhaps we should wait, watch, learn more before making direct contact. Others argued that silence was itself a kind of message, that refusing to respond would seem fearful or hostile, that if we wanted peaceful relations with our cosmic neighbors, we should extend a hand in friendship as soon as possible. The debate continued without resolution. Different factions advocated for different approaches. The United Nations established a committee to study the question, which issued reports and recommendations that were promptly ignored by national governments pursuing their own agendas. Private organizations announced plans to send their own messages, claiming that they did not need official permission to speak to the stars. Meanwhile, the observations continued. Webb and other telescopes kept their eyes on Kepler 442b, gathering more data, refining our understanding. The thermal patterns continued to evolve. The signs of industrial activity continued to spread. Whatever was happening on that distant world was ongoing, dynamic, alive. And then, approximately 18 months after the initial discovery, something new appeared. The observers were not expecting it. By this point, Kepler 442b had become a routine target. Teams took turns monitoring the data stream, looking for gradual changes in the thermal patterns, hoping to understand more about the rhythms of alien industry. They expected slow evolution, the kind of change that happens over years or decades as a civilization grows and develops. What they got was something else entirely. The thermal sensors detected a sudden intense burst of heat from the planet's surface. Not a gradual change like the patterns that had been observed before. A spike, flash, An event. The alert went out immediately. Researchers around the world dropped what they were doing and rushed to analyze the incoming data. Something was happening on Kepler 442b. Something big. Something unprecedented in all their observations. The burst lasted for several hours and then faded. Analysis of the data suggested something extraordinary. The energy release was consistent with a massive nuclear detonation, but the pattern was wrong for a weapon. It was too concentrated, too directed. It looked less like a bomb and more like a rocket engine. The implications hit the research community like a thunderbolt. If this was a launch, it meant that the beings of Kepler 442b had spaceflight capability. More than that, it meant they had propulsion technology far beyond anything humanity possessed. The energy signature suggested velocities that our rockets could never achieve. They were not just a technological civilization. They were an advanced technological civilization. Some researchers hoped it was just a test, an experiment, a probe sent into orbit or toward one of their own moons. That would be remarkable enough, but it would not necessarily concern us directly. Those hopes were dashed over the following weeks. Tracking data revealed that something had left Kepler 442b. Something small, too small to see directly, but its trajectory could be inferred from the gravitational effects on the dust and debris in its path. Something was moving away from the planet, accelerating to a significant fraction of the speed of light. The trajectory was clear, unmistakable. The object was not heading toward any other body in the Kepler 442 system. It was heading toward us, toward Sol, toward Earth. They had launched something into space. The timing was impossible to ignore. The launch came roughly 1,200 years after the first human radio signals could have reached Kepler 442b, allowing for detection time, analysis time, decision time, and construction time. The sequence made sense. They had heard us. They had decided to respond. And their response was not a message, but a probe or perhaps a ship. We have no way of knowing yet what they sent. The object is too small and too far away to observe directly. We can only see its effects on its environment, the subtle perturbations in light and dust that reveal something is there and moving. If it maintains its current trajectory and speed, it will reach our solar system in approximately 100 years. That is an estimate with significant uncertainty. The object could accelerate further, could change course, could be something completely different from what we assume. But the best current guess is that something from Kepler 442b will arrive in our neighborhood within the next century. This changes everything. Again, the discovery of intelligent life was profound. The discovery that they were sending something toward us is something else entirely. We are no longer passive observers. We are participants in an unfolding contact between civilizations. What should we do? How should we prepare? These questions have occupied governments, militaries, scientists, and ordinary citizens since the launch was detected. The answers depend enormously on what the object turns out to be. If it is an automated probe, similar to the Voyager spacecraft we sent out decades ago, then the main challenge is communication. The probe will likely carry some attempt at establishing common ground, mathematical concepts or physical constants that any technological civilization would recognize. We would need to decode its messages and formulate responses. If it is a crewed vessel, the challenges multiply. How do we meet beings who have spent a century traveling through space? What condition will they be in? What do they expect from us? How do we avoid misunderstandings that could escalate into conflict? If it is something else entirely, a weapon, a siege ship, a technological artifact beyond our comprehension, then we are in territory where no planning can help. We would simply have to respond to whatever arrived. The uncertainty is maddening. We know something is coming, but not what. We know roughly when, but not precisely. We have perhaps a century to prepare, which sounds like a long time, but is not. Human institutions think in terms of years, not centuries. The people making decisions today will not be alive to see the consequences. And yet preparations are underway, quietly in research facilities and government agencies around the world. Plans are being made, protocols are being drafted, technologies are being developed. Humanity is doing what it has always done when faced with the unknown. It is trying to understand, trying to prepare, trying to survive. The mood among those who know the details is complicated. There is excitement at the prospect of meeting another civilization. There is fear of what that meeting might bring. There is awe at the scale of what is happening. And there is a strange kind of peace, the acceptance that some things are simply beyond our control. We did not choose this moment. We did not choose to be the generation that discovered we were not alone. But we are that generation. The discovery has been made. The object is on its way. Whatever happens next, nothing will ever be the same. And so we wait, we watch, we wonder. The same three things humanity has always done when confronting the infinite mysteries of the cosmos. But now the mysteries are watching back. Now the cosmos contains not just stars and planets, but minds like ours. Possibly friends, possibly rivals, possibly something we cannot yet imagine. The James Webb Space Telescope continues its observations. Every day, more data arrives, more details emerge. The picture of Kepler, 442b, becomes clearer, even as the questions it raises multiply. And somewhere in the void between our worlds, something is coming. This is where we are. This is the moment we inhabit. The most significant discovery in human history has been made, and its full implications will unfold over generations. We are the beginning of something vast. We are the first to know that we are not alone. And whatever comes next, that knowledge will never leave us. We will carry it forward into whatever future awaits. We will be different because of it. We already are. The story of Earth 3.0 is just beginning. Before we go further, let us pause to consider the incredible chain of events that led to this moment. The discovery of Earth 3.0 was not inevitable. It required centuries of scientific progress, decades of engineering effort, billions of dollars of investment, and the dedication of thousands of individuals who devoted their careers to understanding the cosmos. Think of all the discoveries that had to come first. The understanding that stars are other suns, developed in the 16th and 17th centuries. The realization that the universe is unimaginably vast, established over the following centuries. The discovery of spectroscopy, which allows us to determine the chemical composition of distant objects by analyzing their light. The development of radio astronomy, space travel, digital computing, and countless other technologies. Each of these advances built on what came before. Each was made by people who could not have imagined where their work would lead. The scientists who developed spectroscopy in the 19th century had no idea that their techniques would someday be used to detect signs of life around distant stars. The engineers who built the first rockets had no idea that their descendants would create a telescope capable of peering into alien atmospheres. This chain of progress is humanity's greatest achievement. Not any single discovery or invention, but the ongoing accumulation of knowledge and capability that has transformed us from a species huddled around campfires to one that can detect civilizations 1,200 light-years away. And the chain continues. The discovery of Earth 3.0 will lead to new questions, new technologies, new understanding. Generations from now, our descendants will build on what we have learned and discover things we cannot imagine. The story never ends. It only grows richer and more complex. This is perhaps the most hopeful aspect of the discovery. It shows that progress is real, that humanity can achieve things that once seemed impossible, that the universe is knowable, even if we will never know all of it. In a time when many people are pessimistic about the future, the discovery of another civilization is a reminder that wonderful things can still happen. But the discovery also carries warnings. The beings of Kepler 442b developed technology as we did. They built civilizations as we did. They looked up at the stars and wondered as we do. But their path to this point was surely not easy. They must have faced challenges, crises, moments when their survival was uncertain. They came through, or at least they came through enough to build what we can see. Will we come through our challenges? The threats humanity faces, from climate change to nuclear weapons to artificial intelligence, are serious. Any of them could derail our progress or end our civilization entirely. The discovery of another civilization does not make these threats less real. If anything, it raises the stakes. Now we know that we are representatives of something larger, participants in a cosmic community. Our success or failure matters not just for ourselves, but for our place in that community. Perhaps this is the perspective we need. Perhaps knowing that others are watching, even if from an impossibly distant vantage point, will help us find the wisdom and cooperation to solve our problems. Perhaps the discovery of Earth 3.0 will be the catalyst that finally unites humanity in common purpose. Or perhaps not. Perhaps we will continue to squabble and fight, to put short-term interests above long-term survival, to ignore the warnings until it is too late. The discovery does not change human nature. It only gives us new reasons to hope that our nature is not our destiny. Time will tell. The story is still being written, and we are the ones writing it. Let us take a step back now and consider the James Webb Space Telescope itself, the incredible machine that made this discovery possible. Understanding the telescope helps us understand both the achievement and the limitations of what we have found. Webb represents the cutting edge of human engineering. It is not just a telescope but an observatory, a complex system of mirrors, instruments, shields, and computers working together to capture light from the distant universe and turn it into knowledge. The heart of the telescope is its primary mirror, that 18-segment golden flower we described earlier. Each segment is a hexagon about 4 feet across made of beryllium and coated with a microscopically thin layer of gold. The gold is there because it reflects infrared light extremely well. The segments are arranged in a honeycomb pattern to form a single collecting surface over 21 feet in diameter. To put that in perspective, the Hubble Space Telescope, which transformed astronomy when it launched in 1990, has a primary mirror about 8 feet in diameter. Webb's mirror is nearly 3 times as wide, which means it collects almost 7 times as much light. Where Hubble sees a faint glow, Webb sees detail. But size is not the only difference. Hubble observes primarily invisible and ultraviolet light, the kinds of light our eyes can see or nearly see. Webb observes in infrared, which is invisible to us but carries different information. Infrared light can penetrate dust clouds that block visible light. It reveals the heat signatures of objects too cool to glow visibly. It carries spectral fingerprints of molecules that are invisible at other wavelengths. This is why Webb was essential for studying the atmosphere of Kepler 442b. The molecular signatures that revealed water, oxygen, and methane are most clearly visible in infrared. Hubble could see the planet, but Webb could read its atmosphere like a book. The telescope carries 4 main instruments, each designed for a different kind of observation. An IR-cam, the near-infrared camera, takes high-resolution images in near-infrared light. An IR-spec, the near-infrared spectrograph, spreads light into its component wavelengths to reveal chemical compositions. MIRI, the mid-infrared instrument, sees at longer wavelengths where cooler objects glow brightest. And FGS, the fine guidance sensor and near-infrared imager, helps the telescope point precisely and take specialized spectroscopic observations. These instruments work together to build a complete picture of whatever Webb observes. When studying Kepler 442b, NIR-spec analyzed the atmosphere while MIRI measured the thermal emissions from the surface. The combination gave researchers far more information than either instrument alone could provide. But all of this sophisticated equipment would be useless without the sun shield that keeps it cold. The shield, about the size of a tennis court, blocks the heat of the sun so effectively that the difference between the hot side and the cold side is about 600 degrees Fahrenheit. This allows the instruments to operate at temperatures where they are sensitive enough to detect the faintest signals from the most distant objects. The shield is made of 5 layers of Kapton, a material NASA developed decades ago that can survive the harsh conditions of space. Each layer is incredibly thin, thinner than a human hair, but together they provide insulation that allows Webb to do its work. Operating a telescope this complex and this far from Earth is a remarkable achievement in itself. Webb orbits the L2 point about 1 million miles away, too far for any repair mission. Everything had to work perfectly the first time. There were no second chances. The telescope communicates with Earth through a high-gain antenna that can send data at a rate of about 28 megabits per second. That sounds fast by everyday standards, but it means that the massive amounts of data Webb generates have to be carefully prioritized. Not everything can be sent back immediately. Scientists have to decide what is most important and queue their requests accordingly. This is why the detailed analysis of Kepler 442b took months to complete. The researchers had to share Webb's time with dozens of other projects, each vying for precious observation hours. They had to wait for their data to be transmitted back to Earth. They had to run countless analyses to verify what they were seeing. The discovery did not happen in a moment of revelation, but through the steady accumulation of evidence over time. This is how science works, not in sudden breakthroughs, but in careful, methodical progress toward understanding. This methodical approach is both science's greatest strength and its greatest source of frustration for the public. People want answers. They want to know what the aliens look like, what they think, whether they mean us harm or good. Scientists can only say what the evidence supports, which is far less than what people want to know. But this caution is essential. The stakes are too high for reckless speculation. Every claim about Kepler 442b must be backed by data, verified by independent observers, subjected to the scrutiny of peer review. Only through this rigorous process can we be confident that what we think we know is actually true. Some have criticized this approach as too slow, too conservative, too unwilling to embrace the extraordinary nature of the discovery. Why not simply accept that we have found intelligent aliens and move on to the implications? Why waste time on endless verification when the basic facts seem clear? The answer is that extraordinary claims require extraordinary evidence. We are not talking about a minor scientific discovery. We are talking about the most significant finding in human history. Getting it wrong would be devastating both for science and for society. Getting it right requires patience, care, and intellectual humility. The team of researchers who made this discovery understood this. They checked and rechecked their work. They invited scrutiny. They welcomed challenges. They knew that the only way to convince the world was to produce evidence so solid that no reasonable person could doubt it. Now let us think about what Webb cannot do. Understanding the limitations of our knowledge is as important as understanding the knowledge itself. First, Webb cannot see surface details on Kepler 442b. The planet is simply too far away and too small. Even with Webb's extraordinary resolution, the entire planet is just a tiny point of light. We cannot see continents or oceans. We cannot see cities or vehicles. We can only see the overall thermal signature and atmospheric composition. The patterns we interpret as cities are not images of cities. They are areas of elevated heat in the right locations with the right timing patterns consistent with urban areas. This is a strong inference but not a direct observation. We do not know for certain that our interpretation is correct. Second, Webb cannot detect radio or other electromagnetic communications from Kepler 442b. The telescope is designed to observe infrared light, not radio waves. If the beings there are broadcasting, Webb would not hear them. Other instruments might, but so far none have detected clear signals. Third, Webb cannot track the object that was launched from Kepler 442b with any precision. The object is too small and too far away. We can infer its existence from indirect evidence, but we cannot watch it directly. Our estimate of when it might arrive in our solar system is based on calculations that could be wrong. Fourth, Webb cannot tell us anything about the beings themselves. We can see signs of their civilization but not their bodies, their faces, their lives. We do not know if they are larger or smaller than us. We do not know if they perceive the universe the way we do. We do not know what they value, what they fear, what they hope for. All of that remains unknown and may remain unknown for a very long time. The vast distances involved mean that any detailed contact will take generations. We are seeing the effects of their existence, not meeting them face to face. This is perhaps the strangest aspect of the discovery. We know they are there. We can prove they exist, but we cannot talk to them, cannot see them, cannot touch them. They are as remote from us as figures in a story, except they are real. They are out there right now living their lives, unaware that we are watching, or perhaps aware and wondering about us as we wonder about them. The distance is almost impossible to comprehend. 1,200 light years. Light, the fastest thing in the universe, takes 1,200 years to travel between our worlds. If the beings of Kepler 442b pointed a powerful laser at Earth right now, the light would not arrive until more than a millennium from now. To put it another way, the light we see from Kepler 442b today left that world before anyone currently alive on Earth was born. When we look at that star in our sky, we are seeing the past. The beings there have already lived 1,200 years of history since that light began its journey to us. And the object they launched, if our estimates are correct, it left Kepler 442b about 18 months ago by our observation. But that observation shows events from 1,200 years ago. So the object actually launched about 1,201 years ago in the early 9th century by Earth's calendar. It has been traveling toward us for over a millennium already. We are only now detecting its departure. These temporal paradoxes are inherent in dealing with cosmic distances. Nothing can travel faster than light, which means nothing can arrive before we see it coming. But the warning time we get depends on how fast the object is moving and how closely we are watching. In this case, we have perhaps a century of warning before the object arrives. That sounds like a lot of time, but civilizations do not change quickly. The decisions we make now will shape how our descendants respond to something they will face long after we are gone. This intergenerational nature of the contact is something humanity has never faced before. Wars and treaties are negotiated by people who will live to see their consequences. Scientific theories are proposed and tested within a human lifetime. Even long-term projects like cathedrals or constitutions are completed within a few generations. But contact with Kepler 442b operates on a different timescale. The people who discover the aliens will not be the people who meet them. The people who send the first message will not receive the response. We are dealing with something that transcends individual lives. Something that requires us to think and act as a species rather than as individuals. This is hard. Human beings are not naturally equipped to think on these timescales. We evolved to deal with immediate threats and immediate opportunities. The idea of working toward a goal that will not be achieved for a century feels abstract, almost meaningless. And yet we must. The discovery has been made. The object is coming. Whether we prepare well or poorly, it will arrive. The choice is not whether to face this challenge, but how. Some have argued that the best response is to do nothing. Let our descendants deal with it. They will have better technology, more knowledge, more resources. Why should we, with our limited understanding, try to constrain their options? Others argue that doing nothing is itself a choice with consequences. If we do not start preparing now, our descendants will be starting from scratch. The century we have is a gift. We should use it to learn, to plan, to build. Both arguments have merit. Both have flaws. The debate continues and will continue for as long as this situation persists, which may be for as long as humanity exists. Let us turn now to some of the scientific details that support the discovery. These are complex topics, but understanding them helps us appreciate both the strength of the evidence and the remaining uncertainties. The detection of methane and oxygen together in Kepler 442b's atmosphere is perhaps the most compelling evidence for biological activity. As we mentioned earlier, these two gases react with each other and cannot persist in significant quantities unless something constantly replenishes them. On Earth, that something is life. Methane is produced by biological processes in many environments, including the digestive systems of animals, the metabolism of certain bacteria, and the decay of organic matter in wetlands and ocean sediments. Oxygen is produced primarily by photosynthesis, the process by which plants and cyanobacteria convert carbon dioxide and water into sugars, releasing oxygen as a byproduct. Without life, the methane and oxygen in Earth's atmosphere would react and disappear within a few million years, a blink of an eye in geological terms. The fact that both gases remain abundant indicates that living things are actively producing them. The same logic applies to Kepler 442b. We detected both methane and oxygen in its atmosphere in quantities that cannot be explained by known non-biological processes. The most parsimonious explanation is that the planet has active biological systems producing these gases, just as Earth does. But we should be careful about the term "just as Earth does." The biological processes on Kepler 442b might be very different from ours. The organisms might use completely different biochemistry. They might produce methane and oxygen through mechanisms we have never imagined. We are inferring the existence of life from its byproducts, not from direct observation of living things. This is similar to how you might infer that someone lives in a house by seeing lights turn on and off without ever seeing the person themselves. The inference is reasonable but not certain. The thermal signatures of industrial activity present a similar situation. We see patterns consistent with large-scale heat production in concentrated areas with daily and seasonal variations that suggest organized activity. The simplest explanation is that these are cities and factories producing heat as a byproduct of their operations. But again, we cannot be certain. There might be natural processes that produce similar patterns. Geological activity, unusual atmospheric dynamics, or something we have not thought of might explain the observations without invoking technology. Scientists have worked hard to rule out non-technological explanations. They have modeled the geology, the atmosphere, and the orbital dynamics of Kepler 442b. They have compared the observed patterns to what various natural processes would produce. In every case, the natural explanations fall short. The patterns are too regular, too concentrated, too clearly organized to be the result of chance or natural forces. This does not mean the patterns definitely indicate technology. It means that technology is the best explanation we currently have. As more data comes in, that explanation might be strengthened or challenged. Science is always provisional, always ready to update its conclusions in light of new evidence. The launch of the object from Kepler 442b is harder to explain naturally than the atmospheric or thermal signatures. The energy release was enormous and brief, consistent with a controlled acceleration event rather than any natural phenomenon. The object's subsequent trajectory, accelerating to a significant fraction of light speed and heading in our general direction, is exactly what you would expect from a spacecraft, but unlike any natural object. Could there be a natural explanation? In theory, yes. There are natural phenomena that can accelerate objects to high velocities, such as gravitational slingshots around massive bodies or explosive events in stellar atmospheres. But none of these would produce an object moving from a planetary surface toward a specific destination. The evidence is not airtight. It never is in science. But the preponderance of evidence points strongly toward a technological civilization on Kepler 442b that is aware of our existence and has sent something in our direction. What should we conclude from all this? Different people will draw different conclusions based on their prior beliefs and values. Some will see the discovery as the greatest moment in human history, the beginning of a new era of cosmic community. Others will see it as an existential threat, the harbinger of conflicts we cannot imagine. Still others will remain skeptical, waiting for more evidence before accepting such extraordinary claims. All of these reactions are understandable. The discovery challenges our assumptions about our place in the universe. It forces us to confront questions we have avoided or treated as merely theoretical. It demands that we think about humanity not just as the inhabitants of one small planet, but as members of a cosmic community. Whatever happens next, the discovery of Earth 3.0 will be remembered as a turning point. Before, we wondered. After, we knew. The universe was no longer empty. We were no longer alone. And that changes everything. The night sky has always been humanity's greatest canvas for imagination. Before we understood what the stars were, we saw them as gods, as ancestors, as messages written across the heavens. As our knowledge grew, the mystery deepened. Those points of light became suns, impossibly far away, potentially circled by worlds like our own. Every civilization on Earth has looked up and wondered. The ancient Babylonians tracked the movements of planets and predicted eclipses. The Greeks developed theories about the nature of the cosmos that shaped Western thought for millennia. Chinese astronomers kept meticulous records of celestial events, building a body of knowledge that spanned centuries. In every case, the questions were the same. What is up there? Are we alone? What does the universe want from us? We now have answers to some of those questions. What is up there? Stars, billions of them, many with planets, at least one with a technological civilization. Are we alone? No, we are not. But the third question remains. What does the universe want from us? Or perhaps more accurately, what do the beings of Kepler 442b want from us? We do not know. We cannot know. Not yet. The distances are too vast, the communication too slow, the cultural differences too profound for easy understanding. But we can speculate, we can imagine, and we can prepare. If the beings of Kepler 442b are similar to us in their motivations, they might want many of the same things we want. Knowledge, connection, safety, trade, friendship. These are universal needs, or at least they might be universal needs for any social species that builds technology. But they might also want things that conflict with our interests. Resources, territory, dominance. These too are universal drives, or might be. The history of contact between civilizations on Earth suggests that encounters often end badly for the less powerful party. We might be the less powerful party now. Or they might want things we cannot imagine, things so alien to our way of thinking that we would struggle to recognize them as desires at all. The universe is vast and strange. Evolution does not produce identical results everywhere. The minds of Kepler 442b might be fundamentally different from ours in ways that make mutual understanding impossible. We simply do not know. And that uncertainty is one of the hardest things about this discovery. We have proof that we are not alone. But we have no idea what that means for our future. In the absence of certainty, we fall back on hope. Hope that the beings of Kepler 442b are curious rather than aggressive. Hope that contact will bring knowledge and friendship rather than conflict. Hope that whatever happens, humanity will face it together and come through stronger. Hope is not a strategy. It is not a plan. But it is what we have, along with our knowledge, our technology, and our determination. We have faced the unknown before and survived. We will face it again. The object from Kepler 442b will arrive someday, perhaps in a century, perhaps sooner, perhaps later. When it does, we will learn whether our hopes were justified or naive. Until then, we prepare as best we can and trust that our descendants will rise to the challenge. This is the human story. We explore, we wonder, we reach for the unknown. We make mistakes and learn from them. We face dangers and overcome them. We are small and fragile, living brief lives on a tiny world in a vast universe. But we have minds that can comprehend the cosmos and hands that can build tools to explore it. The discovery of Earth 3.0 adds a new chapter to that story. A chapter that will be written over centuries by generations yet unborn. We do not know how it ends. We may never know, but we are part of it now whether we chose to be or not. And so we continue watching the stars, building our telescopes, sending our hopes and fears into the void, waiting for an answer that may not come in our lifetimes. Living with the knowledge that the universe is stranger and more wonderful than we ever imagined. This is our moment. This is our legacy. This is what we leave to those who come after us. Not certainty but wonder. Not answers but questions. Not an ending but a beginning. The story of humanity and the universe continues. And now, for the first time, we know we are not telling it alone. Let us explore now what life on Kepler 442b might actually look like. This is necessarily speculative, but informed speculation grounded in the science of astrobiology can give us some reasonable guesses about conditions on this alien world. We know the planet is slightly larger than Earth and orbits a star slightly cooler than our Sun. These facts alone tell us something about what life there might experience. The higher gravity would affect everything from body plans to architecture. Creatures that evolved under 1.2 Earth gravities would likely be stockier with stronger bones and more powerful muscles. They might be shorter on average than humans, not because they could not grow tall, but because tall structures are harder to support under higher gravity. Buildings would be built differently too. Tall structures would require more material and more engineering to stand upright. Cities might spread outward rather than upward with buildings that hug the ground. Bridges and other span structures would need to be stronger. The atmosphere, richer in oxygen than Earth's, would support more active metabolisms. Creatures might be able to run faster, work harder, and maintain higher levels of activity for longer periods. Fire would burn more readily, which might have affected the development of their technology. Perhaps they learned to control fire earlier than we did. Or perhaps the danger of fire made them develop different approaches to energy. The light from their star would be redder than our sun's light. Plants on Earth are green because chlorophyll, the molecule that powers photosynthesis, absorbs red and blue light most efficiently and reflects green. On Kepler 442b, where red light dominates, plants might have evolved different pigments. They might be black, absorbing all available light. They might be red themselves, absorbing the complementary colors. They might be something we would barely recognize as plants at all. The sky would look different, too. Our blue sky comes from the scattering of sunlight by our atmosphere. With blue light scattered most under a redder star and with a different atmospheric composition, their sky might appear orange, brown, or even pink. The familiar blue dome that humans have always associated with home would be replaced by something alien. Day and night would follow a different rhythm. The planet orbits its star in 112 Earth days, but we do not know how fast it rotates on its axis. If its day is longer than Earth's, creatures might have evolved different sleep patterns. If its day is shorter, they might be used to a faster cycle of activity and rest. Seasons might exist or might not, depending on how tilted the planet's axis is relative to its orbit. Earth's seasons come from our 23-degree axial tilt. A planet with no tilt would have no seasons. A planet with a more extreme tilt would have more extreme seasons. We do not yet know what Kepler 442b's tilt is. The oceans, if they exist as we think they do, might look very different from ours. The color of the water depends on what is in it and what light illuminates it. An ocean under a red sky might appear purple or brown or some color we do not have a name for. Creatures swimming in those waters might have evolved to see wavelengths of light we cannot perceive. All of this is speculation, of course. We are imagining a world based on limited data and general principles. The reality might be wildly different from anything we envision. Evolution is creative in ways that cannot always be predicted. The beings of Kepler 442b might have taken paths we cannot imagine. But this speculation is valuable because it reminds us that alien means truly alien. The beings who built the thermal signatures we observe did not evolve under our sun. They did not breathe our air. They did not grow up looking at our stars. Everything about their world, their bodies, their minds would be different from ours. And yet they built, they organized, they created technology that we can detect from 1,200 light-years away. Whatever they are, they share with us the drive to understand and alter their environment. They share the spark of intelligence that leads to civilization. Perhaps that common ground will be enough. Perhaps two minds, however different in their nature, can find ways to communicate if they both want to. Perhaps the beings of Kepler 442b are already trying to reach us, sending messages we have not yet learned to decode. Or perhaps the differences will prove insurmountable. Perhaps their minds work in ways so alien that communication is impossible. Perhaps they perceive the universe so differently that we have no common reference points. Perhaps what looks like civilization to us is something completely different to them. We will not know until contact is made, and contact, if it ever comes, will be the work of generations. The psychology of this discovery is fascinating to consider. How do human minds cope with the knowledge that we are not alone? How do we process information that fundamentally reshapes our understanding of our place in existence? Studies of how people have reacted to the discovery reveal a wide range of responses. For some, the news brought a profound sense of relief. They had always felt that a universe without other intelligence would be somehow incomplete, somehow wasteful. The confirmation that others exist validated their intuition that the cosmos must be populated with minds. For others, the news brought anxiety. The unknown is frightening, and nothing could be more unknown than beings who evolved on a different world under a different star. What do they want? What are they capable of? What might they do if they decide we are a threat or an opportunity? Still, others experienced a curious sense of insignificance. Humanity had grown accustomed to thinking of itself as special, as the only species capable of wonder and creation. Now that uniqueness was gone, we were one civilization among at least two, possibly among millions. That knowledge diminished our sense of cosmic importance. But alongside the insignificance came something else. A sense of belonging, of membership in a larger community. We were no longer alone in the void, no longer the only witnesses to the grandeur of existence. Others were out there looking at the same stars from different angles, asking the same questions in different ways. Philosophers have debated for millennia whether the universe has meaning. If nothing exists to appreciate it, does beauty matter? If no one observes the stars, do they truly shine? These questions seemed abstract until the discovery. Now they have weight. The universe has at least two appreciators. The stars shine for at least two sets of eyes. This may seem like a small consolation in the face of such overwhelming uncertainty, but it is not nothing. The knowledge that others exist, that intelligence is a feature of the cosmos rather than an anomaly, gives our existence a context it lacked before. We are part of something. We do not know exactly what. We do not know if that something is hostile or friendly, chaotic or orderly, destined for greatness or doomed to extinction. But we are part of it. And that connection, however mysterious, is a kind of comfort. The religious implications of the discovery have been debated endlessly since the announcement. Different faiths have responded in different ways, some embracing the discovery as evidence of divine creativity, others struggling to reconcile it with doctrines that seem to assume human uniqueness. For many believers, the existence of other intelligent beings poses no theological problem. If God created the universe, why would God create only one intelligent species? The vastness of creation suggests a creator who delights in variety, who would naturally populate the cosmos with diverse forms of life and mind. For others, the questions are more difficult. What does salvation mean for beings who never heard of Earth's religious traditions? Are they fallen? Are they saved? Are concepts like sin and redemption even applicable to creatures with completely different histories and possibly completely different natures? These questions have no easy answers, and they may never have definitive answers. But the discovery has forced religious thinkers to grapple with them in ways that were previously optional. The beings of Kepler 442b are not hypothetical. They are real. Whatever theology humanity develops going forward must account for their existence. The scientific implications extend far beyond astrobiology. The discovery has implications for every field that touches on the nature of intelligence, the conditions for life, and the future of technological civilization. Physicists are revisiting questions about the fundamental constants of the universe. Why are the laws of physics tuned in a way that allows matter to form, stars to burn, planets to coalesce, and life to emerge? The anthropic principle suggests that we can only exist in a universe compatible with our existence. But the discovery of another civilization adds weight to this principle. Two independent emergences of intelligence in one galaxy suggest that intelligence may be a robust phenomenon, one that arises across a wide range of conditions. Biologists are reconsidering what we think we know about evolution and the origins of complexity. Life on Earth began relatively quickly after the planet cooled enough to support it. If life arose quickly here, perhaps it arises quickly wherever conditions permit. The fact that Kepler 442b has life suggests that our experience may be typical rather than exceptional. Sociologists and anthropologists are studying how human societies respond to transformative discoveries. The discovery of Earth 3.0 is comparable in some ways to the Copernican revolution, which displaced Earth from the center of the cosmos, or to Darwin's theory of evolution, which displaced humanity from a privileged position in the natural order. How do societies adapt to such shifts? What patterns emerge? What dangers arise? Economists are modeling the potential impacts of long-term contact. If trade with another civilization ever becomes possible, even if only in the form of information exchange, what would that mean for human economies? How would intellectual property work across interstellar distances? What would we have that they might want and vice versa? These questions may seem premature given the vast distances involved, but the discovery has a way of making the distant future seem more immediate. If something is coming from Kepler 442b, and if that something represents a civilization that has been watching us and has decided to make contact, then these questions are not merely academic. They are practical concerns that someone will have to address. The military and security implications have also received intense attention. Though much of that attention is classified, governments around the world have established committees and offices dedicated to assessing the potential threats posed by contact with an alien civilization. The scenarios being studied range from benign to catastrophic. At one extreme, the beings of Kepler 442b might be peaceful explorers eager to share knowledge and establish friendly relations. At the other extreme, they might be hostile conquerors, viewing humanity as an obstacle to be removed or a resource to be exploited. Most experts believe the truth is likely somewhere in between. A civilization capable of interstellar travel would have capabilities far beyond ours. But that does not necessarily mean they would use those capabilities aggressively. On Earth, the most technologically advanced societies are generally also the most peaceful, at least in terms of outright conquest. Perhaps the same pattern holds across the cosmos. But no one is willing to bet humanity's future on optimistic assumptions. Contingency plans are being developed for every scenario from friendly first contact to hostile invasion. Defense systems are being studied. Communication protocols are being drafted. The goal is not to start a war, but to be ready for any eventuality. This preparation has its critics. Some argue that any attempt to defend against a civilization capable of interstellar travel is futile. If they can cross the void between stars, they can certainly overcome any defense we might mount. Better to rely on diplomacy and hope for the best than to provoke them with shows of military readiness. Others argue that preparation is essential precisely because we cannot be sure of their intentions. A civilization that sees us preparing to defend ourselves might be more inclined to treat us as equals rather than as helpless primitives to be dominated. Strength, they argue, invites respect. The debate continues without resolution, as do most debates about matters so far beyond our experience. We are making decisions in the dark, guided only by principles and intuitions developed in a context very different from the one we now face. What wisdom can guide us in such unprecedented circumstances? Perhaps only the wisdom of humility. We do not know what is coming. We cannot know. All we can do is face the unknown with courage, with openness, and with the hope that the universe is ultimately friendly to intelligence and to life. The ethical questions raised by the discovery of Earth 3.0 are profound and may never be fully resolved. What are our obligations to beings we have discovered but cannot communicate with? How should we behave toward a civilization we can observe but not interact with? What rights do they have, and what rights do we have in relation to them? Some argue that we should leave them alone, that our observation of their world is already a kind of intrusion, and that we should minimize our impact on them as much as possible. Under this view, any attempt to contact them or send probes would be inappropriate, a form of cosmic interference that we have no right to perform. Others argue that contact is inevitable and desirable, that the discovery of another civilization is the most important event in human history, and that we should pursue understanding and communication with all possible vigor. Under this view, the opportunity to learn from another intelligent species far outweighs any concerns about interference. Still others take a more practical stance. The beings of Kepler 442b have already sent something toward us. The decision to engage has been made, just not by us. Whatever our ethical qualms, we need to be prepared for what is coming. These debates echo older debates about contact between human civilizations, about the ethics of exploration and colonization, about the responsibilities of more powerful societies toward less powerful ones. But they also transcend those debates because the scale is so much larger and the differences so much more profound. When Europeans encountered indigenous peoples in the Americas, both sides were human. They shared biology, evolutionary history, and fundamental cognitive structures. They could learn each other's languages, interbreed, exchange ideas and technologies. The encounters were often tragic, but communication was possible. With the beings of Kepler 442b, we have none of those guarantees. They might be so different from us that understanding is impossible. They might be so similar that conflict is inevitable. We simply do not know. What we do know is that the discovery has changed us. Even if nothing else ever comes of it, even if the object from Kepler 442b turns out to be something other than what we fear or hope, the knowledge that we are not alone will shape human culture forever. Children born today will grow up in a universe that contains other minds. They will study history that includes our first discovery of extraterrestrial intelligence. They will imagine futures that include contact with beings from other worlds. Their sense of what is possible will be broader than ours was. This is the gift of the discovery. Regardless of its outcome, we know more than we did. The universe is richer than we thought. And humanity's story is part of a larger story, one that encompasses not just our world, but worlds beyond count. The James Webb Space Telescope continues its mission every day. It gathers more data from the depths of space. Some of that data might reveal more about Kepler 442b. Some might reveal other worlds with other civilizations. The discoveries have only begun. And somewhere out there, moving through the darkness between stars, something is heading toward us. A probe, a ship, an artifact. We do not know. It has been traveling for over a millennium already. It will travel for decades or centuries more before it arrives. When it does, we will face the ultimate test of our species. Can we communicate with beings utterly unlike ourselves? Can we find common ground with minds that evolved under different suns? Can we approach the unknown with curiosity rather than fear? With openness rather than hostility? We will find out. Not today, not soon, but eventually. And whatever happens, we will face it as what we have always been, a small, curious, determined species on a small, beautiful world, looking out at the stars and wondering what else might be there. Now we know something is there. Something is coming, and we are ready as we can be, to discover what that means. The light from Kepler 442b continues to reach us, carrying news from a world we can never visit in person. In that light are the answers to questions we have not yet thought to ask. In that light is the story of another civilization, its triumphs and struggles, its hopes and fears. In that light is a mirror reflecting back at us the image of what intelligent life can become. We look at that light and we see ourselves. Not literally, of course. The beings of Kepler 442b are not human. But in building, in organizing, in reaching for the stars, they have done what we have done. They have taken the raw material of existence and shaped it into something more. They have become, in their own way, children of the cosmos, as are we. The discovery of Earth 3.0 is not the end of a story, but the beginning of one. It is the moment when humanity realized it was not alone. The moment when our perspective shifted from the provincial to the cosmic. Whatever happens next, we will always be the generation that learned the truth. And the truth is wonderful, terrifying, and full of possibility. The universe is alive. Intelligence exists beyond our world. The questions we have asked since we first looked up at the stars have answers, even if we do not yet fully understand them. This is what the James Webb Space Telescope has given us. Not just data, not just images, but a new understanding of our place in existence. We are part of something larger than ourselves. We always were. Now we know it. And knowing it, we go forward into the unknown, into the future, into whatever awaits us among the stars. The story continues. It always has. It always will. But now, for the first time, we know we are not writing it alone. The technical challenges of detecting life across interstellar distances are immense. Understanding them helps us appreciate both what has been accomplished and what remains to be done. When astronomers talk about detecting biosignatures, they mean chemical or physical signs that life might produce. On Earth, the most obvious biosignatures are gases that life generates. Oxygen, methane, nitrous oxide, and ozone are all produced or influenced by biological processes. Finding these gases in an exoplanet's atmosphere does not prove life exists, but it makes life a more plausible explanation. The challenge is that detecting these gases requires extraordinarily precise measurements. The planet itself is invisible against the glare of its star. We cannot photograph it directly. Instead, we watch the star and look for tiny changes that tell us a planet is there. The transit method used by the Kepler Space Telescope detects planets by watching for the tiny dimming that occurs when a planet passes in front of its star. The dimming is minuscule, often less than 1% of the star's total light. Detecting it requires instruments of incredible sensitivity and observations that continue over months or years. Once a planet is detected, analyzing its atmosphere requires even more precision. During a transit, some of the star's light passes through the planet's atmosphere before reaching us. Different molecules absorb different wavelengths of that light. By comparing the light during a transit to the light at other times, astronomers can figure out which wavelengths are being absorbed. This tells them what molecules are present. But the signal is tiny. The atmosphere is a thin shell around the planet, and only a small fraction of the starlight passes through it. The absorption features are subtle, often buried in noise. Extracting them requires sophisticated statistical techniques and careful calibration. This is where the James Webb Space Telescope excels. Its large mirror collects more light than any previous space telescope. Its infrared sensitivity lets it detect absorption features that are invisible at other wavelengths. Its position in space, far from the thermal noise of Earth, gives it a clean view of the faint signals from distant worlds. Even so, the detection of biosignatures on Kepler 442b pushed Webb to its limits. The research team had to combine observations from multiple transits to build up enough signal. They had to model the star's own emissions and subtract them from the data. They had to account for every possible source of error and verify their results through independent methods. The result was one of the most detailed atmospheric analyses ever performed on an exoplanet. And it showed something remarkable: a world with water, oxygen, and methane in proportions that strongly suggest biological activity. The detection of technosignatures, signs of technology rather than just life, is even more challenging. The thermal patterns that suggest industrial activity on Kepler 442b are faint echoes of heat, barely distinguishable from the general thermal glow of the planet. Interpreting them requires assumptions about what technology would look like from our vantage point. We assume that cities produce concentrated heat. We assume that industrial processes follow daily and seasonal rhythms. We assume that transportation networks connect urban areas. These assumptions are based on our own civilization, which may or may not resemble theirs. The researchers were careful to acknowledge these uncertainties. Their papers described the thermal patterns as consistent with technological activity rather than proof of technological activity. The language is deliberately cautious because the claims are extraordinary. But the patterns are there, regular, concentrated, organized, different from what natural processes would produce. The best explanation we have is that they represent the work of intelligent beings. The detection of the object launched from Kepler 442b was different from the other observations. It was not a subtle signal extracted from noise, but a clear, dramatic event. The energy release was visible. The trajectory was measurable. The implications were unmistakable. Something left that planet and is heading toward ours. The tracking data comes from multiple sources. Webb detected the initial launch through its thermal sensors. Ground-based telescopes measured the object's effect on the dust and debris in its path. Radio telescopes listened for any communications the object might be transmitting. Together, these observations paint a picture of something small, fast, and deliberately aimed. We cannot see the object directly. It is too small and too far away. But we can see what it does to its environment, and that tells us it is real. The implications of this detection are hard to overstate. The atmospheric biosignatures and thermal technosignatures were remarkable but ambiguous. The launch of an interstellar object is neither. It is a deliberate act by a technological civilization, a statement of capability and intent. We do not know what the intent is. The object might be a peaceful probe similar to our own Voyager spacecraft, carrying greetings and information about its creators. It might be a scientific instrument designed to study our solar system in detail. It might be a colonization seed, carrying the means to establish a presence in our neighborhood. It might be something we have not imagined, something that makes sense in the context of their civilization but would be incomprehensible to us. Something whose purpose we will only understand when it arrives and reveals itself. The uncertainty is maddening but unavoidable. We have about a century to prepare, perhaps more, perhaps less. We will spend that time watching, learning, and debating what to do. The scientific community has responded to the discovery with intense activity. Research groups around the world are developing new instruments and techniques to study Kepler 442b in greater detail. Plans are being made for future space telescopes that could image the planet directly, revealing its surface features and perhaps even its inhabitants. Theoretical work has accelerated, too. Physicists are exploring the limits of interstellar travel, trying to understand what technologies might allow a civilization to cross the gulf between stars. Biologists are modeling what alien life might look like based on the conditions we have inferred for Kepler 442b. Social scientists are studying how human societies respond to existential discoveries, hoping to guide our collective response. International cooperation has increased, though not without friction. Some nations want to take the lead in preparing for contact. Others want to ensure that any response represents all of humanity, not just the most powerful countries. Diplomatic negotiations are ongoing, complicated by the fact that no existing framework addresses the situation we now face. Private organizations have entered the picture as well. Space companies are proposing missions to study the incoming object. Communications firms are designing protocols for potential exchanges with the aliens. Technology entrepreneurs are investing in research that might give humanity an advantage in any contact scenario. The public response has been varied. Some people are fascinated by the discovery and eager to learn more. Others are frightened and want to ignore or deny it. Many are simply going about their lives, treating the news as interesting but not immediately relevant. This diversity of responses is healthy. Humanity is not a monolith. We contain multitudes. The discovery of Earth 3.0 affects all of us, but it affects us differently depending on our beliefs, our circumstances, and our temperaments. What matters is that we face the discovery together. Whatever conflicts exist among us, we are all in this situation. The beings of Kepler 442b do not know or care about our internal divisions. To them, we are all simply inhabitants of Earth, the pale blue dot orbiting a yellow star in an unremarkable part of the galaxy. Perhaps the discovery will help us see ourselves that way too, not as separate nations or factions, but as one species on one world, facing a challenge that transcends our differences. Perhaps the knowledge that we are not alone will make us value each other more. That may be the greatest gift of the discovery. Not any specific knowledge about the aliens, but the perspective that comes from knowing they exist. We are small. The universe is vast. We have neighbors, and we need to figure out together what that means. The James Webb Space Telescope is a marvel of human achievement. But it is just the beginning. Future telescopes will see farther and more clearly. Future probes will travel to other star systems and send back direct observations. Future generations will know things about the universe that we cannot imagine. We stand at a threshold. Behind us is everything humanity has been. Ahead is everything we might become. The discovery of Earth 3.0 marks the boundary between the two. Cross that boundary and we enter a new era. An era of cosmic awareness. An era when we know, not just suspect, that intelligence is woven through the fabric of existence. An era when our decisions must account for beings beyond our world. It is a humbling prospect. It is also an inspiring one. We are not alone. The universe that seems so empty and indifferent is actually full of minds, full of lives, full of stories we have only begun to glimpse. What could be more wonderful than that? The object from Kepler 442b continues its journey through the darkness between stars. Every second it moves thousands of miles closer to us. Every year the distance shrinks. Eventually, perhaps within the lifetime of children born today, it will arrive. And then we will learn what it carries, what message, what technology, what intent. We will learn something about the beings who sent it. We will learn something about ourselves. Until then, we watch and wait and wonder. The same three activities that have defined humanity since we first became conscious. We watch the stars, hoping they will reveal their secrets. We wait for the answers that may be coming. We wonder what it all means. The discovery of Earth 3.0 has not changed these fundamental activities. It has only given them new urgency and new depth. We always wondered if we were alone. Now we know we are not. We always watched the sky for signs of otherness. Now we have found them. We always waited for the universe to reveal itself. Now it has begun. The story continues. It will continue for as long as there are minds to tell it. And thanks to the James Webb Space Telescope, we now know that there are other minds out there telling their own stories, looking at their own stars, wondering about their own place in the cosmic order. Perhaps someday our stories will meet. Perhaps we will learn to understand each other across the vast gulf of space and time and biology. Perhaps we will become friends, or at least respectful neighbors sharing this corner of the galaxy. Or perhaps not. Perhaps the differences will prove too great. Perhaps the encounter will end badly for us or for them or for both. We cannot know, but we can hope, and we can prepare, and we can face the unknown with the courage and curiosity that have always defined the best of humanity. That is what the discovery of Earth 3.0 demands of us. Not fear but courage. Not despair but hope. Not isolation but connection. We are not alone. And knowing that, we can never go back to the ignorance we once enjoyed. The universe is calling. It is time to answer. As the sun sets over Earth tonight, millions of people will look up at the stars. Some will find Lyra, the constellation that holds the star Kepler 442. They will see a faint point of light indistinguishable from 1,000 others. But they will know that around that star orbits a world where other beings look up at other stars and see our sun. Two civilizations separated by 1,200 light-years, connected by nothing but photons and curiosity. Two species evolved on different worlds, shaped by different histories, but united in the fundamental drive to understand. We do not know what the future holds. We do not know if contact will bring friendship or conflict. We do not know if we will survive the encounter or be forever changed by it. But we know this much: we are not alone. The universe contains other minds. And somewhere out there, perhaps at this very moment, beings as curious and as brave as we are wondering what we are like. May they find us worthy of their attention. May we find them worthy of ours. And may the story we write together be one of understanding, of peace, and of shared wonder at the incredible cosmos we all inhabit. The discovery of Earth 3.0 is the beginning of that story. The rest is up to us. And with that thought, we come to the end of our journey through this incredible discovery. From the initial detection of an Earth-like world to the shocking realization that something is already there. From the technical marvel of the James Webb Space Telescope to the profound philosophical questions raised by contact with another civilization. We have explored one of the most significant events in human history. The beings of Kepler 442b remain mysterious. We know they exist. We know they build. We know they have sent something toward us. But we do not know who they are, what they want, or how they will react when contact finally comes. That uncertainty is both terrifying and wonderful. It reminds us that the universe is vast beyond comprehension, that our knowledge is limited, that there are truths out there we have not yet imagined. But it also reminds us of our own significance. In all that vastness, we emerged. We developed consciousness, curiosity, technology. We built telescopes that could peer across interstellar distances and detect the fingerprints of life. We alone, of all the species on Earth, asked the question and found the answer. We are not alone, but we are remarkable. And whatever happens next, we will face it with the courage, the creativity, and the determination that have always been our greatest strengths. Thank you for joining us on this exploration of one of the greatest discoveries in human history. If you enjoyed this video, please hit that like button and subscribe to Cosmic Drift. We will continue to bring you the latest and most profound discoveries from the universe. Until next time, keep looking up. The stars have never been more interesting than they are right now. And somewhere among them, something is looking back. But our story is not quite complete. There are dimensions to this discovery we have not yet explored. Threads of thought and wonder that deserve our attention before we close this chapter. Let us linger a while longer in the profound mystery of what has been found. Consider for a moment the sheer improbability of this moment in history. For billions of years, Earth orbited its star in solitude. Life emerged, evolved, diversified. Countless species came and went, living and dying without ever wondering what lay beyond the blue sky. Then came humanity, and in a cosmic eye blink, we developed the technology to peer across the void and find others who had done the same. The timing is staggering. If human civilization had emerged a million years earlier, we would not have had the technology to make this discovery. If it had emerged a million years later, we might have missed whatever window of opportunity exists for contact with the beings of Kepler 442b. We happen to exist at exactly the right moment with exactly the right tools to detect their presence. Is this coincidence? Or is there something deeper at work? Some scientists have proposed what they call the anthropic principle, the idea that the universe must be compatible with the existence of observers because if it were not, there would be no one to observe it. Perhaps something similar applies here. Perhaps civilizations that develop technology inevitably discover each other because that is what technological civilizations do. Or perhaps we are simply lucky. Lucky to exist at all. Lucky to have developed intelligence. Lucky to have built the James Webb Space Telescope. Lucky to have pointed it at the right star at the right time. The universe is under no obligation to make sense to us. Things happen or they do not, and we make of them what we can. Whatever the explanation, here we are, aware of another civilization for the first time in history, confronting questions our ancestors could only dream about, facing a future that has suddenly become much more complicated and much more interesting. The history of human thought about extraterrestrial life stretches back millennia. Ancient philosophers debated whether other worlds might exist and whether they might be inhabited. Lucretius, the Roman poet, wrote that the universe must contain other Earths because the laws of nature would produce similar results wherever similar conditions existed. Giordano Bruno was burned at the stake in part for his belief that the stars were other suns with their own planets and their own inhabitants. In more recent centuries, the question became more scientific. Astronomers discovered that the stars were indeed other suns, that the planets in our solar system were other worlds, that the universe was incomprehensibly vast. The possibility of extraterrestrial life seemed to grow more plausible with each new discovery. But there was always doubt. We were the only example of intelligent life we knew. Perhaps we were unique. Perhaps the conditions that produced us were so rare that we were alone in the cosmos, surrounded by empty worlds and dead moons. The discovery of Earth 3.0 has settled that doubt forever. We are not unique. Intelligence arose at least twice in our galaxy. And if it arose twice, it probably arose many more times than that. The implications ripple outward endlessly. If intelligent life is common in the galaxy, then the universe is full of civilizations we have not yet detected. Some might be younger than ours, still developing the technology to reveal themselves. Some might be vastly older, possessing capabilities we cannot imagine. Some might have risen and fallen long ago, leaving only ruins and echoes. This is the Fermi paradox that we mentioned earlier, but now it takes on new dimensions. The beings of Kepler 442b are one data point, but they are a crucial one. They show that technological civilizations can persist long enough to be detected. They show that such civilizations produce visible signatures of their existence. They show that the galaxy is not the silent, empty place some pessimists feared. But they also raise new questions. If civilizations like theirs are common, why have we not detected more of them? The James Webb Space Telescope can study only a tiny fraction of the habitable planets in our galaxy. Are there civilizations orbiting other stars waiting to be discovered? Or is there something special about Kepler 442b that made detection possible there but not elsewhere? Perhaps the beings there are unusually advanced, producing stronger signatures than most civilizations would. Perhaps they are unusually close, making detection easier. Perhaps they deliberately made themselves visible, wanting to be found. Or perhaps we have just been searching in the right way with the right tools, and other civilizations will be found as we continue our efforts. The search will certainly continue. The discovery of Earth 3.0 has transformed the search for extraterrestrial intelligence from a speculative enterprise to a productive one. We have proved that such civilizations exist. Now we need to find out how common they are. New telescopes are already being planned with this goal in mind. The Habitable Worlds Observatory, proposed for launch in the late 2030s, will be designed specifically to image Earth-like planets around nearby stars and analyze their atmospheres for signs of life and technology. It will be able to study dozens of potential targets, building up a statistical picture of how common inhabited worlds really are. Ground-based observatories are being upgraded, too. The extremely large telescope in Chile, with its mirror nearly 40 meters across, will be able to study exoplanet atmospheres in unprecedented detail. The Square Kilometer Array, a network of radio telescopes spanning 2 continents, will listen for signals from civilizations that might be deliberately broadcasting. Within a few decades, we might know not just that one other civilization exists, but how many there are in our cosmic neighborhood. We might have a catalog of inhabited worlds, each with its own characteristics and its own questions to answer. We might begin to understand the demographics of intelligence in the universe. Or we might find that Kepler 442b is an anomaly, that such civilizations are rare after all, that we got lucky in our first discovery and will find few others. That too would be significant information, though perhaps not as inspiring as a galaxy teeming with life. Whatever we find, the search will teach us something about our own place in the cosmos. We will understand better how unusual or how typical our situation is. We will have context for evaluating our own achievements and our own prospects. We will see ourselves not just as Earthlings, but as one example of a broader phenomenon, intelligence arising from matter and seeking to understand itself. This shift in perspective may be the most important consequence of the discovery. For all of human history, we have thought of ourselves as the only minds in a mindless universe. That assumption shaped our religions, our philosophies, our sense of our own importance. Now it must be revised. We are not the only minds. The universe contains others, and that changes everything. Consider how different human history might have been if we had known this from the start. If our ancestors had looked up at the stars and known, not just suspected, but known that other civilizations existed out there, would our religions have developed differently? Would our philosophies have emphasized different values? Would we have been more or less likely to destroy ourselves in wars and conflicts? These questions have no answers, but they illuminate how profoundly the discovery affects our understanding of ourselves. We are not writing on a blank page anymore. We are joining a conversation that has been going on, at least in the case of Kepler 442b, for who knows how long. The beings there have their own history, their own cultures, their own achievements and failures. They have faced challenges we might learn from. They have developed solutions we might adopt. They have made mistakes we might avoid. Or they might have nothing to teach us. Their path might have been so different from ours that no lesson transfers. Their values might be incompatible with ours. Their technology might be based on principles we cannot understand. Contact might reveal only how vast the gulf between different intelligences can be. We will not know until contact happens. And contact, real contact, is still a long way off. The object they launch toward us will take decades or centuries to arrive. Even when it does, understanding it might take more time. Decoding any messages it carries, if it carries any, could be the work of generations. True communication, if it is possible at all, might require advances in linguistics, mathematics, and philosophy that we have not yet made. In the meantime, we watch. We learn what we can from the distant light of their world. We prepare as best we can for an encounter we cannot fully imagine. This is the situation we find ourselves in. Not first contact, not yet, but first awareness. The awareness that contact is possible, that it will happen, that we need to get ready. Getting ready means different things to different people. For scientists, it means developing better instruments and better theories. For diplomats, it means building international frameworks for representing humanity. For military planners, it means preparing for scenarios ranging from peaceful exchange to existential conflict. For ordinary people, it means adjusting their understanding of the universe and their place in it. All of these preparations are underway. Some are visible, reported in news media, and discussed in public forums. Others are secret, conducted by governments and agencies that do not share their plans. The full scope of humanity's response to the discovery is probably known to no single person. But the response is happening slowly, awkwardly, with many false starts and disagreements. Humanity is beginning to act as a species facing a common challenge. We are not good at this. Our history is full of conflict and division. But the discovery of Earth 3.0 gives us a reason to try. Perhaps this is the greatest gift the beings of Kepler 442b could give us. Not any specific technology or knowledge, but the motivation to unite. To see ourselves as one civilization on one world, facing an unknown future together. Whether we rise to that challenge remains to be seen. Human nature does not change quickly. The same drives that led to cooperation and achievement have also led to war and destruction. The discovery of another civilization might bring out the best in us or the worst. But at least now we have the opportunity. We know what is at stake. We know that we are not alone, that our actions might be observed, that our fate might be connected to the fate of beings beyond our world. That knowledge is a kind of gravity, pulling us toward a future we must face together. The night sky has never looked the same since the discovery was announced. Those who know the story see it differently now. The stars are not just points of light anymore. They are potential homes. The darkness between them is not empty. It is full of possibility. This is the new reality we inhabit. A reality where intelligence is known to exist beyond Earth. Where the universe is not just vast but populated. Where the questions our ancestors asked have begun to receive answers. We do not know all the answers yet. We may never know them, but we know more than we did. And that knowledge is precious. The James Webb Space Telescope will continue its mission for years to come. Every day it sends back more data, more images, more insights into the nature of the cosmos. Some of that data will refine our understanding of Earth 3.0. Some will reveal entirely new discoveries. The universe has not run out of surprises. And somewhere beyond the reach of any telescope, the object from Kepler 442b continues its journey through the dark between stars, across the unimaginable distances of interstellar space. It moves steadily toward a destination it may or may not know is there. What does it carry? What message? What technology? What intent? We will find out eventually. Our descendants will face that moment and make the choices we cannot make for them. In the meantime, we do what humans have always done. We wonder, we work, we hope, we prepare. We tell stories to make sense of our experience and pass on our wisdom to those who come after. This story, the story of Earth 3.0, is now part of the human heritage. It will be told for as long as there are humans to tell it. It will shape our understanding of ourselves and our place in the universe. It will be the beginning of a larger story, one that might not end for millions of years. That is a humbling thought. We are characters in a story we cannot finish. But we can play our parts with courage and grace. We can be worthy of the moment we have been given. The beings of Kepler 442b looked up at their sky and wondered just as we did. They developed intelligence and technology just as we did. They reached out toward the stars just as we are doing. Perhaps in the end that is the deepest truth the discovery reveals. Not that we are different, but that we are the same. Different bodies, different histories, different worlds, but the same drive to understand. The same curiosity that looks at the unknown and wants to explore it. The same spark of mind that transforms matter into meaning. We are kin across the light years. We are family, though we have never met. We are participants in a cosmic process that produces intelligence wherever conditions allow. And now we know it. Now we have proof. Now we can face the future knowing that whatever we find out there, we will not find it alone. The stars are calling. The universe is waiting, and humanity, for all its flaws and failures, is ready to answer. That is the message of Earth 3.0. That is what the James Webb Space Telescope has given us. Not just a discovery, but a destiny. We are going to the stars. We may not know how or when. We may not know what we will find when we get there. But we are going because that is what intelligent life does. It explores. It expands. It seeks to understand the cosmos that gave it birth. The beings of Kepler 442b understood this. They sent something toward us because they wanted to know what was out there. They reached across the void because the void was there to be crossed. We will do the same. We will reach back. We will cross the distances that seem so impossibly vast today, but that our descendants might navigate as easily as we cross oceans. We will meet them or their descendants or the civilization that comes after them. And when we do, we will have this moment to remember. The moment when we first knew. The moment when the universe revealed that it was not empty after all. This is that moment. This is when it began. And everything that happens next will flow from this beginning. The discovery of Earth 3.0. The proof that we are not alone. The first step on a journey that might last forever. What could be more wonderful? What could be more terrifying? What could be more human? We looked at the stars and saw ourselves reflected back. We asked the question and heard an answer. We reached out into the darkness and found someone reaching back. This is the story of our species in one sentence. This is what we do. This is who we are. And now, finally, we know that we are not the only ones. The cosmos is stranger and more wonderful than we ever dared to dream. The universe that seems so cold and empty is actually warm with life, buzzing with intelligence, full of stories waiting to be discovered. We are not alone. We never were. We just did not know it until now. That knowledge is our inheritance and our responsibility. We must use it wisely. We must face the future with open eyes and open hearts. We must be ready for whatever comes, whether it brings hope or fear, wonder or danger. We can do this. We have faced the unknown before and survived. We have confronted challenges that seemed insurmountable and overcome them. We have taken the raw material of existence and shaped it into something meaningful. We will do it again. We will face the beings of Kepler 442b or their emissaries. We will decode their messages and send our own. We will begin the conversation that might continue for millennia. And in doing so, we will become something more than we are now. Something greater. Something worthy of the cosmos that produced us. That is the promise of this moment. That is what the discovery offers us. Not just knowledge, but transformation. Not just answers, but new questions. Not just an ending, but a beginning. The story of Earth 3.0 is our story. Now we will write its next chapters with our choices and our actions. We will determine whether it is a tragedy or a triumph. The choice is ours. The future is ours. The stars are ours. Let us be worthy of them. And with that thought, let us close this exploration of one of the most remarkable discoveries in human history. The James Webb Space Telescope has shown us that we are not alone in the universe. Kepler 442b is home to another civilization. One that has sent something toward us across the vast distances between stars. What happens next is uncertain. What it means is still being debated. But one thing is clear. The universe is no longer what we thought it was. It is richer, stranger, and more full of possibility than we ever imagined. Thank you for taking this journey with us. Thank you for wondering, for questioning, for caring about what lies beyond our small world. Thank you for being curious. That curiosity is humanity's greatest gift. It is what led us to build telescopes and rockets, to explore the oceans and the continents, to ask the questions that led to this moment. It is what will carry us forward into whatever future awaits. Keep being curious. Keep looking up. Keep wondering what else might be out there. Because now we know something is, and that changes everything. The discovery of Earth 3.0 will be remembered as the moment when humanity grew up. The moment when we stopped seeing ourselves as the center of creation and began to understand that we were part of something much larger. The moment when the universe stopped being a mystery to be solved and became a community to be joined. We do not know what comes next. We do not know if contact will bring joy or sorrow, wisdom or danger. We do not know if the beings of Kepler 442b will become our friends, our rivals, or something we cannot yet imagine. But we know that they exist. We know that intelligence, that precious spark that makes existence meaningful, has arisen more than once in this vast cosmos. We know that we are not alone, and knowing that, we can never go back to the small, isolated existence we lived before. We are citizens of the universe now, whether we are ready for it or not. Until we meet again among the stars. This is Cosmic Drift signing off. The universe is vast. Intelligence is precious. And we are not alone. Sleep well. Dream of the cosmos. And remember, somewhere out there right now, other minds are dreaming too.